let's get started. Welcome everybody. It's 1 o'clock on Tuesday, and we have our next HDF clinic here today. Last time I checked, there weren't any questions, and there aren't any questions right now. But I'm going to pause here and ask for those who are attending, are there any questions that you would like to ask now, or I'll pause many more times. But here's your chance. Any questions about HDF5? No. Okay, then we'll just go through our usual motions here. Yeah, I still owe you an answer about the file locking changes from 1.12.1 if we'll bring them into the 1.10 release. Last week's highlights, again, this is sort of a selection of posts on the forum that caught my eye. There's a lot more on the forum going on that I can capture here, but then yeah, I get to choose. There were two great announcements. One was that the HSD, the highly scalable data service that used to be available only on AWS and Amazon Web Services, is also available on the Microsoft Azure cloud platform now. And I have the link here to the forum post itself. But then the easiest way, as is the case with AWS, to get started with HSDS on this platform is to go to the Azure marketplace, and the link is here. And there you will find sort of the offer itself, where you can configure the deployment and so forth, and then basically hit the go button, and lo and behold, in a few moments you will have a running HSDS instance on Azure, and so you can go check it out, and it's available now. The other announcement was the announcement of VFD SWMR Beta 1 release, and I think we'll have time today. I'll talk a little bit more about SWMR and VFD SWMR. And yeah, so it's out there. It's in a feature branch of our GitHub repo. The link is here. There's also an interesting YouTube movie that goes with that covers a little more than just VFD SWMR. It also covers the so-called onion and split VFDs. And but a substantial portion of that presentation from our European Hub event is dedicated to VFD SWMR, and if you just want to get an idea of what is this about, then I encourage you to watch that movie. And then if that catches your attention and you really want to take a deep dive into how this is implemented and so forth, here is the VFD SWMR RFC, and that has all the technical details, the design, the testing, and so forth, in-depth descriptions. And I encourage you to sort of check that out. I can take a break and ask again, are there any questions about SWMR? Not about SWMR, about HDF5 in general, then feel free to speak up or interrupt me. Otherwise, yeah, I'll just move on. What else has been happening in the forum? There was basically one issue, a practical issue, if that affects you. A user with the latest HDF5 1.12.1 release found an issue with building that release using CMake, and with HDF5 enable parallel, meaning doing a parallel build that supports MPI. And the user reported it, and it turns out, so it's fixed already. It turns out sort of a mistake in a CMake file, and it's fixed in this pull request. I have not checked if that pull request has been merged already, but it's out there and it's available. So it's really just changing. If you want to fix it for yourself, it's really just changing, I believe, 2 lines in a CMake file somewhere. So there are no code changes necessary or anything. It's really just 2 lines in a CMake file that need to be fixed, and then it builds just fine and so forth. But it's great that, again, there's an active community out there, and they find these issues and report them, and then we'll fix them, and that's the way it should be. Great. So that was there. There were other things again, but some things we've covered already in the past, and then some things like I can compile this with these options or something like that. Maybe that's not of interest for a general audience. That's more of a small audience. But otherwise, it was relatively quiet. But then, hey, maybe a lot of people are on vacation, and yeah, or have other things to do. I'll pause here and ask once more, are there any questions about HDF5, the use of HDF5 tools, documentation, anything? No? Okay, then I'll just move on. And it's kind of topical, since we had that VFD SWMR Beta 1 release, assuming you haven't used SWMR before, or you have used SWMR before, but then you might ask, well, how is VFD SWMR different from the existing SWMR? Let's use this opportunity to talk a little bit about what is SWMR, first of all, even if you haven't used SWMR before, and then what is new with VFD SWMR compared to the first implementation. So SWMR, it kind of rolls off the tongue, but it's just sort of an abbreviation that stands for single writer, multiple readers, which is called a pattern. And the main use case is, in a way, what I would describe in double quotes as you have multiple processes in the sense of operating system processes. And these processes are writing, well, one of them is writing to an HDF5 file, and other processes are reading from an HDF5 file. And you might say, well, what's the big deal? These processes, there are all kinds of protocols and mechanisms for them to communicate, and then that way to collaborate. But the point here for SWMR is actually that you want that collaboration between processes to occur without any synchronization or communication between these processes. In other words, specifically for this, since it says single writer, multiple readers, obviously there's only, this pattern is intended only for a single writing process, is you would like one or more processes reading from an HDF5 file that is actively being written by another process with the constraint or non-constraint that there is no communication necessary. No communication or inter-process communication should be necessary between the readers or between any individual reader and the writer. They don't have to coordinate. The writer will just write its thing. So let's assume you have some kind of data acquisition system, a camera system, a detector, or something like that, and just happily writing away data. And then readers that open the file for reading, and these readers may show up at any point in time and then say, let me see what's there in terms of data sets, and then, oh, here's a data set, and then I'm going to read from it. And maybe if it's one of the data sets that's actually being actively written, when you read 5 minutes later, some new data has shown up, and then you can do sort of, in a way, if it's an analysis task or something like that, you can do, call it online in double quotes analysis. You can actually start analyzing, processing data before before the whole acquisition might be over, and sometimes the acquisition takes several days or even weeks and so forth. So that way you don't have to wait for the whole acquisition campaign to finish before you can start reading and inquiring and starting to analyze data. Now, if you think about it, this use case of sort of process collaboration without communication is actually a pretty big ask, because you should consider, for example, these three high-level questions. Number one is, how do we ensure that what the readers are reading is actually not invalid, inconsistent, or corrupt data? Because, as we said, there's no inter-process communication taking place in particular between readers and writers. So it's not that the writer can signal to the readers and say, hey guys, I just finished reading this, I flushed it, and now you can go ahead and start reading. That's not the case. There is no inter-process communication occurring. I mean, it might still occur, but not for the purposes of this. Otherwise, that wouldn't be novel or interesting, because that's possible without SWMR. But there's no inter-process communication. So how do we ensure, especially with something like HDF5, where the data is sort of arranged in a sort of graph-like structure, if you wish, how do we make sure that that is navigable at all times? But then also when you come to individual data sets, for example, that when the writer is actively writing to a particular data set and actually extending the data set, so let's assume it's some kind of maybe chunk data set and keeps appending chunks, well, how can you ensure that the things that the reader sees is really a fully written complete chunk rather than parts of it and so forth? And all these things sort of, whether it's corrupt data, a file that appears inconsistent because a certain update just hasn't yet been committed to the file and so forth. So that's a big challenge right there. Number two, the question is, well, what about these updates or changes? When do they become visible to readers? Are they instantaneous, or is there a certain lag? But then what we can say about this lag or this delay, can we bound that somehow, that we could give readers a guarantee that when we sort of, let's say we want to set up a timer on the reader side where the reader says, well, I want to make sure I don't miss the latest data, I sort of stay on top of things. So can we guarantee that within 5 minutes, 5 seconds, 10 milliseconds or something, you pick a number, that changes become visible when a timer like that expires and the reader sort of, it cannot happen that a reader sort of falls totally behind, where for the longest time they just don't see any updates, they somehow get left behind or something like that. And then even if you have solved all the technical problems in some way, then the question is, well, your technical solution, based on what kind of assumptions is that, how is that implemented? Does it require any special hardware? Does it require any special software? Those are all interesting questions. So this is actually a pretty big ask. Now, some of these technical problems, well, to arrive at a workable solution, were overcome, and there was an initial release of SWMR functionality in HDF 5.1.10.0, which I believe was released in March of 2016. So that's now over 5 years ago. And you might say, well, you did it, so why SWMR VFD or VFD SWMR, and why now? Well, there were certain limitations. As I said, this is sort of a big ask, and there were certain limitations in the first implementation implementation that made it usable and everything, but didn't cover really maybe the full breadth and generality of what some would expect from SWMR implementation, single writer, multiple reader. And just to name a few, the main limitations sort of seen by users were, number one, this first implementation was limited to, in a way, data set appends or modifying a value in an existing data sets. They did not cover the case of that, hey, the writer might actually create a new group, or the writer might actually create a whole bunch of new data sets or attributes and so forth, or the opposite, delete certain things. The first implementation of SWMR did not cover those, and it was really a, what I would call, data set append only solution. Number two, you might call it, does it require any special software support? Well, in the following sense, that this first implementation relied on strict write ordering, so that the writes to the file system would occur and processed by the file system in exactly that order, and that writes were atomic, so that you could never, when something was written, it was really written as a complete unit and become visible as that modified complete unit, rather than sort of first part of it being written and then later another part of it being written. And that is critical because many file systems out there don't do this. The most prominent and most widely used file system that doesn't guarantee neither the strict write ordering nor the atomic writes is the network file system, NFS. Even in the latest, I believe, version 4, it doesn't do that, and probably for good reasons, because the NFS implementers say, well, that's really not, that's detrimental to our performance and not really critical to 80% plus of NFS users. And a third very important concern for us is that this first implementation touches a lot of parts of the HDF5 library. In practical terms, that means that the maintenance cost for these features, for this feature in particular, SWMR, is very high, because let's say you discover a defect and then, well, first of all, tracking down where that defect actually occurs. If it's just located in a relatively isolated part of the library, that would be okay. But if it's sort of a combination of things that reaches all over the place, that is very costly, and yeah, so a high maintenance cost of this implementation is a big issue, because we all know, especially if you are the maintainer of a software, that's where your real cost, your long-term cost is. The implementation cost for a feature that is there to stay pretty much forever is in the maintenance cost. It's not the implementation cost. It's really the long-term maintenance, bug fixing, and sometimes feature enhancement and so forth. Okay, so those were some of the limitations of this first implementation, and each in and of itself would be worth considering. And but then to overcome these issues and provide some additional capabilities, sort of BFD SWMR was conceived most by a small team, basically the authors of the SWMR RFC, John Mainzer, Dana Robinson, and Wei-Ling Choi. And they came up with a design that addressed all these issues, and it addressed them in a very interesting and innovative way, I think. So what this VFD SWMR implementation brings, and that is the implementation of which you can now get a beta release, the first beta release. It brings you, well, first of all, it allows arbitrary item and object creation / deletion. So there is no longer this limitation that you cannot create new items, new groups, new data sets, add attributes, and so forth, or delete them. That's no longer a restriction. You can make those changes and they will become visible to the reader. So the writer can make those changes to the HDF5 file and they become visible to readers without any problems. The second sort of shortcoming of this first implementation that this addresses is really that the first implementation did not make any guarantees about the delay or the duration, the time between the writer having written someone and it becoming that change or that update becoming visible to readers. There was just no way to guarantee that in any shape or form, let alone even if you could have made that guarantee, it wasn't configurable. Whereas with the new implementation, it is actually configurable to a degree. And there is this hard bound, which I wouldn't go as far as calling it real time, but sort of very from the perspective of sort of change propagation, pretty high performance. It also addresses this fundamental maintenance issue, and that's why it sort of got this additional prefix here, VFD SWMR, which is to suggest that rather than having an implementation that sort of reaches into all kinds of different parts of the library, the implementation is really confined to the, as we call it, VFS, virtual file system level, or the specific implementation of a virtual file system is a virtual file driver. So it is really confined to this, if you want to use the metaphor of high levels of the library up and low levels of the library down, it's sort of the VFD layer sits sort of at the bottom of the HDF5 library, and it is really confined. This implementation is confined to this VFD level, and that makes it much more maintainable. And of course, it will be a task to remove all that code that was introduced all over the library to support the first SWMR implementation. But nevertheless, it's worth it just in terms of the long-term maintenance and the cost and the fixing bugs. At least then it's confined to the VFD level, which makes it easier to debug, easier to maintain, and whatnot, and also more performant. It also addresses, it relaxes these requirements in terms of strict write ordering, atomic write guarantees, and so forth. Now, with this new approach, it is actually possible to support sort of more relaxed environments, relaxed about ordering of these operations and atomicity, such as NFS, or also, as they are now very popular in cloud-based environments, for example, but also on-prem and in on-prem clouds, object stores. So all these things can be supported with this new implementation, which would not have been possible, at least not in a very straightforward way, with the old implementation. Now you might be wondering, well, how is all this done? Well, you will have to read the RSC for that, but I can give you a high-level idea of how it's done. And the idea is basically, as we all know, we've gone over that in the past, is if you want to call it the state of an HDF5 file that's being modified, is in a way sort of a hybrid creature. It's not something that lives completely in memory or completely in storage, but it's sort of it's a conglomerate. It's an aggregate of two: the state and memory, typically something like the metadata cache content and so forth, and the bytes on disk, so to speak. Not talking about hardware sort of things that the operating system does and so forth. So the idea is basically to say, hey, we want to capture states of this combination, and in this case, it's mostly the volatile combination that sits in memory of the metadata. When we know that the union of what's on disk and what's in memory is actually taken together, represents the consistent state of an HDF5 file, that if all those bytes would live in storage, then any reader would recognize this as a valid HDF5 file and would not have any problems, not encounter any issues with traversing the file, reading elements and whatnot. And so the idea is to basically, at certain points in the execution, to create snapshots of the metadata when it's known to be in a consistent state. And it turns out those points are actually rather easy to find, because it's actually always when you enter an API function and when you leave an API function, you know that at those 2 points, the metadata is definitely in a consistent state. And so those would be the natural places to capture these snapshots of metadata. Now, the clue with respect to the reader is then, okay, you have these snapshots, but since we talked about no IPC, so the readers and the writer and the readers will typically run in different address spaces. So we can, and we said no IPC, which means no shared memory segment or something like that. So how can they share that snapshot? Both the readers and the writer can see, of course, the bytes on disk, but how can the readers actually get a hold of these snapshots? Well, the idea is you just create these snapshots in a separate file or something that gets persisted in some kind of storage, and that doesn't necessarily have to be the same file system in which the HDF5 file resides. It could be some other storage, some other device. And what the readers basically do is they use a combination of these snapshots with the bytes that are available in the HDF5 file, taken together to read a consistent HDF5 file. And yeah, periodically these snapshots will be, older snapshots will be replaced by newer snapshots, and that's how readers can always read an HDF5 file in a consistent state and so forth. And of course, by making this periodic with a frequency that you can control, but also there are, of course, technical details, and I mentioned that here, but I refer you to the RFC, is you need the ability to bound the size of metadata changes to a degree, and you can achieve that or make that manageable through the use of page buffering, which was actually page allocation and page buffering was also introduced, I believe, in 110. I don't, maybe in 110.1 or 110.2. So that's something that was there as infrastructure already, but now sort of gets used in a new interesting way. So that combination of page buffering and bounding the size of metadata changes makes it possible that you can do this guarantee, that real-time and double quotes guarantee that basically says that after no more than a certain period or epoch or something like that, these changes will become visible. Anyway, there are lots of technical details. Maybe next time or the time thereafter we'll do quick demonstration. Although if you watch the YouTube video, I believe there was a demonstration there. If not that, it was actually at the previous hub last year, where I think someone gave a demo. But we'll come back to this and do a little demo here, so just that you can see some code, and the code from a user perspective, the code is actually not very different from an HDF application. It's just a matter of configuring these VFDs properly. Anyway, I think time is up. That's it for today. Thank you for coming, and I'll see you next week. Submit your questions, and we'll come back next time. Thank you. Bye.